Hello everyone, my name is Jatin Pandey. Again brought you the important topics of in science, important laws in science. Previous videos were must be very helpful for these people, and if you go through them, it will be very beneficial for you in understanding the laws of physics and applying them in the examination, how to solve them, apply them in exam, and how to get the best out of these topics. Now we will start with important laws in science, and today's topic is heat. We will be discussing about the heat. So first of all, the very common topic, very basic of the heat is the zeroth law. Heat is actually a potential energy. It's something function like a potential energy with an characteristic similar to it. How it is characteristic similar to it? Heat flows from higher potential towards the lower potential. As we know that electricity flow from higher potential to the lower potential. In the same way, heat flows from higher potential to the lower potential. In this case, in case of heat, the potential here means the temperature. Heat is the energy that flows from higher temperature to lower temperature. And zeroth law is what? An application of this principle. Zeroth law states that the two bodies having a different temperature will keep on exchanging the heat among them till the temperature of this body comes in equilibrium, thermal equilibrium. If temperature is T1 of body A, T2, T3 of body C, and T2 of body 1, then this body will be in a state of dynamism, in a state of change of the heat till T1, T2, and T3 remains same. My body is exchanging heat continuously to the room, and this process will continue till the temperature of my body and this room comes in thermal equilibrium. This is what the zeroth law is all about. You must have experienced the heat while you hold something hot material. This is because the energy starts flowing from the hotter body to your body, and it will continue till the temperature of both comes into a thermal equilibrium. So this is all about the zeroth law. Now we move to the second one. Second, the very basic is again that the first law thermodynamics is state based on the conservation of energy. It clearly states that energy can neither be created nor be destroyed. Conservation of energy. From this, we can also have conservation of mass. Conservation of mass. Conservation of mass. This first law states that energy of a closed system and its mass remain same. It cannot be destroyed, neither be created nor be destroyed. So its definition, in form of definition, we can say the first law of thermodynamics states that energy, neither the energy nor the mass can be created or destroyed, but it could be converted from one form to the another form. For example, we all know this famous formula of Einstein, E is equal to mc square. Here from this we can understand that energy can be converted to mass, can be converted to speed, but it cannot be destroyed, neither be created. Whatever mass of the universe, it is constant. It will not get created, it not will get destroyed in any condition. Similar goes with energy. Energy of the universe is constant. It will not change, neither it will be created, nor it will get destroyed. Will change its form, either into the mass or into the velocity, any other form, but cannot be destroyed. This is the very first law of the thermodynamics. This law, this brings into the picture of in form of internal energy. Like we can say, as I said, this closed system will have constant energy, but in case we applied a force work on this system, then what will happen? Then we will still say the energy of system will remain same. Work that we have applied will be used to raise the internal energy, and the heat, as if we applied the work on this body, its internal energy will increase. Internal energy of its particle will increase because the heat will produce. If we compress something, it will get hot. Why it will get hot? Because the heat is produced. Heat is produced, it will increase its internal energy, and this heat will get we start exchanging with this environment. The body will start exchanging its heat with the environment. So we can say the work we have given to the body will be used in increasing the heat energy, internal energy, and the heat will be exchanged between the system and the environment. This is the first law of thermodynamics and its application. So what you have to remember in this very topic is that it's based on the conservation of energy. Energy can neither be created nor be destroyed, and it gives rise to the internal energy. A concept of internal energy. Internal energy is the energy that a body is carrying. This room is carrying certain internal energy. If we use some external pump to fill the air in it, then the internal energy will rise because the compressed air is entering into the room. At the same time, temperature of the room will increase. It will start exchanging heat from the external environment. As till now, there it is in form of thermal equilibrium with the environment. As we know, zeroth law, it is in equilibrium. But as the compressor pump heat compressed air, this room temperature will increase, and it will exchange start changing heat with the environment. This is what will happen. So this is all about the first law of thermodynamics. Now we come to the second law of thermodynamics. Second law of thermodynamics states that provides the how the energy at the higher temperature have higher significance. It gives rise to the a certain thing named as entropy, which says that energy at the higher temperature has higher significance than the heat energy at the lower temperature. This is what the second law of thermodynamics state. First is about the conservation of energy. Second is about the energy at higher temperature has higher significance. It gives the direction of the flow of energy. First of take the example of a rod. It's a heated rod. It is heated from this end, Q. Q1 is energy supplied on this end, and T2 is the temperature on this side, T1. Now the first law will state if this is an isolated system, this rod is an isolated system, then the energy of the system will remain same. This rod will be remain in heated state throughout its life. But it does not. But the second law of thermodynamics give us the indication of the possible direction of the heat within the body, possible direction of the heat energy within the body. As we know, this temperature is T1. It's a higher temperature. So this energy will move from higher temperature to the lower temperature. This is what significance is given by the second law of thermodynamics. It also states that it is impossible to convert energy into another form with 100% efficiency. Energy conversion with 100% efficiency is not possible. With 100% efficiency is impossible. This is what this second law talks about. So what we have to learn keep in mind about second law of thermodynamics, that it gives rise to the concept of energy, which state that the energy at entropy, we state that the energy at higher temperature had higher significance. It gives the direction of the flow of heat energy. Then comes a something we can application of this second law of thermodynamics, Planck's Kelvin-Planck's statement. It states that it is impossible for an engine, heat engine, any work producing energy to work with only one source of temperature. All right, it means, as we have understood in the second law of energy thermodynamics, that it's impossible to have 100% conversion of the energy. This statement is an application. What is saying that it is not possible to have an engine producing energy with only one source of heat. It must be having two, because in this condition, if it's having only one source, it means it is converting all the energy supplied to it into the work with having the 100% efficiency. So Kelvin said that this is not possible at any condition. So to have a working system, we need to have a system engine that is exchange heats between two systems, T1 at higher temperature and T2 at lower temperature. This is Q1, this is W1, and the heat that it uses is used heat is Q1 minus W1. This is the Kelvin-Planck statement. Now there is another statement as well, very related to this things. Second law of thermodynamics is the closure statement. It states that it is impossible to supply heat. It is impossible for an engine to supply heat to a body at higher temperature without using energy from any other source. All right, if it is not possible for this engine to continuously supply heat to the body at T1 temperature without using any work done, this is not possible. So to have a working body, we need to have a heat in refrigerator which absorbs some heat while exchanging the heat between the two temperature. Here T1 is greater than T2, T1 is greater than T2. So how we can sum up this? That to supply a heat, it is impossible for a body to transfer heat from lower temperature to the higher temperature without the use of any external work done. We need to have some external work done to supply heat from lower temperature to higher temperature, like we heat refrigerator, heat pump. All right, this is what second law of thermodynamics start. Hope you have understood the zeroth law, first law of thermodynamics, and third law of this corollaries of the second law of thermodynamics. We will bring up you more interesting such videos in the upcoming videos, so stay tuned. Thank you very much.